So now what we're going to be doing is we're going to be working on problem 4.27, and this one is going to be on page 127. This one's similar to the Democratic Republicans problem you have on your homework. So we have got 10 workers. So let's make a table of our workers. We've got John, and I'm going to separate them by male and female. So I've got John, Ray, I've got Marcus, sorry guys, my marker's not working too well here. We have John, Ray, Marcus, we've got Phil and Justin. And for the girls, we've got Megan, Linda, we've got Carol, we've got Sue and Amanda. All right. So it says, consider the following workers. If a committee of 5 is to be chosen from the workers, what is the probability that it must include at least 2 women? So committee of 5. With at least 2 women. All right. So we have a total of 5 women and 5 men. And out of all of the men and women, if we add them both together, we have 10 total. To choose from. So now if we come down here, we're pulling a committee of 5 with at least 2 women. So at least 2 women, what does that mean? Well, we can have 2 women, we can have 3 women, we can have 4 women, or we can have all 5 of our committee be women. But when it says at least 2, it means that 2 is included, and we need at least 2. So we can go up to 5. We can't go over 5 though, because remember, our committee only has 5 in it. So now how do we set this up? I always feel like setting up the denominator is the easiest, and this is going to be done with combinations. So a combination is going to be n over x, and x stands for the number pulled from the group and n stands for the total number. All right. So now, when we're doing this, we can come over here and say, actually I'm going to go down here, and with that n over x, we can say, okay, what's the total number in the group, the n? And the total number in the group is going to be that 10 total, the total number of people we have to choose from. And the x, the number we're pulling from the group, is going to be the 5, the committee of 5. So in the denominator, because remember, we're looking for the probability of choosing at least 2 women. So in the denominator, I have to have my n combination x. So my n we've established is 10, and my x we've established is 5. 10 of the total number of people that we have to choose from, and 5 because we're pulling a committee of 5 out of the total 10. And the reason this is in the denominator is because we have to take into consideration in the denominator, remember the total number of ways there are to draw a committee of 5 out of a total of 10 people. And that's what a combination does. It's a function on your calculator, or you can do it by hand, that says, hey, if I have a committee, a really large committee of 10, or I'm sorry, if I have a really large population of 10, and I want to draw 5 people from that 10, I need to know the total number of ways that I'm able to draw 5 people out of a total of 10 people. And we could have done this for the die problem too. We could have said that, okay, I have a total number of 2 die, and I have 6 sides to each die, which makes a total of 12 faces. So we could have done 2 combination 12 and gotten the same answer, the 36. But here, this combination, what it represents is the total number of ways that we can pull 5 out of 10. But let's talk about the numerator. The numerator is the hardest part of this whole thing. And so let's just put that denominator in our back pocket. Well, I've just pasted my chemistry stuff in here. We're just gonna ignore that for a moment. There we go. Okay. So now let's talk about the numerator. We are going to think back on what they're looking for. So we're looking for a probability, which is why we have the denominator and we need a numerator. But if they're looking for the probability of pulling 2, 3, 4, or 5 women for the committee. Because they said at least 2 in the problem. So now, what we want to do is we want to say, okay, for my first set, this is going to be my women, and this is going to be for my men. And this has to be a combination as well, because we want to know how many ways there are to pull, and let's just start with 2, and we'll work our way up. How many ways there are to pull 2 women out of a total of 5 women? Because there are 5 total women to choose from in the population, right? That's why we're picking 5. Not because it's the committee size, but because there's a total of 5 women to pick from. And we're picking 2 out of those 5 women. So that's why the 2 is in the X spot and the 5 is in the N spot. Now, we've got our combination for women established. Let's look at the combination for men. For men, we have to kind of compensate for that. So if I have 2 women out of a committee of 5, 5 minus 2, that means I have to have 3 men to fill my committee. And on top, there's going to be a 5 for a total of 5 men. Now we're done with 2. I'm going to cross it off. And we're going to move on to 3. I cannot have 2 women and 3 women and 4 women and 5 women. I can have 2 or 3 or 4 or 5, which means that we're going to be adding. Wherever there's an or, you know you're going to add. So here, we're multiplying these two combinations because we can have 2 women and 3 men. Now let's set up the set for 3. We're going to say, okay, I have my women, and I have my set for men, and I'm going to say there's a total of 5 women and 5 men, and now for the women, I'm going to pull 3, which means that if I have a committee of 5, I've picked 3 women for the committee, I have 2 more spaces left in the committee to fill, so I'm going to fill it with men. And we're going to do that again. We're going to say, or we can have, and I'm going to come down here, we can have a committee of 4 women and 1 man, or we can have a combination of 5 women, which means the committee is all 5 women, and that would mean there are 0 men. This whole thing is going to be our numerator. So now if you turn to your calculators and you do 5 combination 2, and I'm going to erase the women and men so I can write what the combinations are. If you type 5 combination 2 into your calculator, you're going to get 10, and we're multiplying here because they're right next to each other, times 10, plus, because it's or, we're going to have 10 here, times 10 here, plus, because there's or, 5 here, times 5 here, plus, because there's an or, 1 times 1. And when I am done solving for all of this and doing all of the math, I get 226. There are 226 total ways to pull 2 or 3 or 4 or 5 women out of each respective sample. So a total of 226. Now I ended up right here for a reason, because this is our numerator and this right here is our denominator. So now all we have to do is solve the combination for our denominator, and this we end up getting 252 total ways that we can pull 5 people from a population of 10. So this turns out to be 226 divided by 252. So we got 226 out of 252. And if I turn this into a decimal, I'm not going to, but if I turn this into a decimal, that will be the probability of choosing a committee of 5 with at least 2 females. Now for B, it wants to know if Linda must be chosen as a member of the committee, what is the probability that the committee contains at least 2 females? So we're going to come over here. We're still looking at least 2 females, but Linda has to be drawn. So we still have the 5 in the committee, and we still have a total of 10 people to choose from. So our denominator is going to be the same. Our denominator is going to be that 252. Now the numerator, and I'm going to do the first one and see if you can catch on here. So we can have 2, 3, 4, 5, not 6, 2, 3, 4, or 5 females, women, in the committee. Because we're still looking for at least 2 females in the committee. But Linda has to be chosen. So the first set that we're going to do for the numerator is going to be 1 over 1. And this is going to have an L for Linda. We're pulling Linda out so she gets her own set, that lucky lady. Now we can set aside our sets for men and women. Women and men. If we pull Linda out of the 5 total women that there are in the population, there are going to be 4 women left in the population of 10 to choose from. All right. So then we're doing 2 first. If we're pulling 2 women from the 5, Linda is a woman. So that means that I've already drawn 1 because I drew Linda. And I only need 1 more to make that 2. Because 1 plus 1 is 2. I'm drawing 2 women. And 4 plus 1 is 5. This accounts for the 5 total women that there are to draw from. And for the men, it's going to be 5. We aren't pulling out any men. So 5 total men. And if we're drawing 2 women, we have to draw 3 men to fill our committee of 5. Now that the 2 is done, we're going to say, or we can have Linda, out of the 4 other women to draw, we can draw 2, because we're looking at 3 now. And we know that 2 plus 1 is 3 women, because Linda is a woman. We can say that for the men, we will have, out of the 5 to draw from, if we have 3 women, we can have 2 men. We're going to add and say, or we can have 1 for Linda. Notice how Linda is showing up in each of these scenarios, because each of these different sets is talking about a different scenario. What if we were to pull 2 women? What if we were to pull 3 women? What if we were to pull 4 like we're doing now? And pull Linda out of those. So here's 4 for the number of women left to draw from. And now if we're drawing 4 women out of the total of 5 women, Linda has to be drawn, and Linda's a woman. We have 3 more spots left for women to draw. So we have to draw 3 randomly from the women. And for the men, out of 5, if there are 4 women, we only have space for 1 man in the committee of 5. Or we can have Linda, four other women, and 0 men. And now when we go through and we do the math for all of these combinations, we are going to end up getting 1 for Linda times 4 times 10 plus 1 times 6 times 10 plus 1 times 4 times 5 plus 1 times 1 times 1. So when we do all the math, we get 121 total ways to pull a committee of at least 2 women if Linda has to be chosen. So for the denominator, I know this, I said the denominator doesn't change, but the denominator actually has to change. So, and I'll tell you why. If we pull Linda out of the population and out of the committee, because she must be chosen, there are only 9 people left to choose from, because Linda is over here. Linda is a certainty, but the other 9 are only possibilities. So if Linda is pulled from the population, 10 minus 1 Linda is 9. And then we'll have a 4 down here. We pulled Linda. We have a committee of 5. So 5 minus 1 is 4. So we have 9 total people to choose from. And we're pulling 4 from that 9. And that's when Linda is already pulled out from the group. So for this, if we do the combination, we'll get 126 ways. So in the end, we've got 121 ways to pull at least 2 females for a committee. And that's with Linda chosen already, out of 126 total ways. And if we convert this to a decimal, we get 0.960317. And that is how to do the combinations. For your Democrat and Republican problem, one thing that I wanted to stress to you is that I have a committee of 6. 6 in committee. They want to know the probability of a majority of Democrats and a majority of Republicans. So if I have 3, if I have 3 Democrats and 3 Republicans, that is not going to be, neither of them are going to be in the majority. It's going to be half and half. But if I have 4 Democrats and 2 Republicans, the Democrats are just, it's the very first time they're in the majority. And if I have 4 Republicans and 2 Democrats, that's the very first time the Republicans are in the majority. So that's how to think about that one. Otherwise, this problem is very similar to that one. If you have any questions, let me know. I do have tutoring hours tomorrow from 11 o'clock until noon in iSelf on the 2nd floor. And I believe that Shookieing is also going to be in the tutoring center tomorrow on Wednesday. do check the tutoring schedule, and I will get you guys a schedule of the exam day hours as well as soon as that's available to me. Have a great night.